Well, hi there. What we're going to look at are the two sections 6.2 and 6.3, and we're going to go over some factoring techniques. Now, these are not the only techniques out there. I'm going to spend most of my time on just two of those. So here, factoring is a way of breaking something into parts. And we break our polynomials into parts so that we can solve them, is the main purpose of this. And then once we solve them or find the zeros, like we talked about in the last section, then we know where it crosses the x-axis. So this is a process when you have a polynomial and you're asked to find the x-intercepts or the zeros. This is the process that you will use, is to break it down so that it looks something like this. All right. Well, let's go ahead and let's look up here and see if there's any information. In this section, we will cover how to factor general trinomials of the form ax squared plus bx plus c. We will first talk about an easier case when the leading coefficient is a 1. So in all of our x squareds, a squareds, whatever variable we're using, it won't be 2x squared, it'll just be x squared. But quickly generalize the process that will work for all trinomials. Factoring trinomials is essentially just doing reverse FOIL method. So again, this is why I kind of concentrated on the FOIL when we were multiplying, because we're going to be using this to reverse the process. Let's look at how we FOIL. So in other words, if we were to multiply these two together, all right, this has been factored, we would get, using the FOIL, we take the first times the first, x times x gives us x squared, okay? And then we take the outside and multiply those. The I is inside and multiply those. And then they're similar, they're like, so we add those together for the next term. 5x and 3x is 8x. And then we take the last term in each of these parentheses, each of these binomials, we take the last one in each of them and multiply them. 3 times 5 is 15. All right, so what we're going to do in when we factor, if we, to factor, in order to solve, we're going to reverse. So here you multiply. Okay, so that finding the product. And going backwards, this is called factoring. So what you do is you break it into parts so that you can solve those individual parts. If this is set equal to 0, I know that either x plus 3 is 0 or x plus 5 is 0, and you solve that. And that is the solution to this when this is set equal to 0. So we're going to look at how to go from here backwards so that we have parentheses. Okay, now we touched on that in 6.1 where we were looking for the greatest common factor, and that's what we're going to do here. It's kind of like the reverse FOIL method. Now, first off you do is we know we're going to be factoring this, and the very first step that people forget is to look for the greatest common factor from 6.1. Is there something that I could divide each of those by evenly? Well, the numbers in front, the coefficients are 1, 5, and 6. And there's nothing that goes into 1, 5, and 6 other than the number 1. So there's not a coefficient I could take out. Now, the 6 doesn't have a variable, so there's not a variable to take out either. And it's really important to remember to do that step. You can have a tendency to forget because you'll do problem after problem where you don't need that. And then all of a sudden it shows up. So again, try to make it a habit to look for the greatest common factor, pull that out first before we start to factor. But in this case, there isn't one. All right, so given this right here, what I'll do is I'm going to set up my parentheses because we're going to be making it look like this here. So I set up the parentheses and I give space inside the parentheses because I'm going to be writing variables and numbers inside. Okay. Now we use the reverse FOIL. We have FOIL. So we set up our parentheses using these two. So this is what people don't like because it's a trial and error process. You try to put numbers in and see if it works. If it doesn't, you erase and try something else. And people really don't like that. It's kind of tedious to do a trial and error, but that's what you do. All righty. So here, for the first term, what would give us, what two numbers would multiply together to give us that first term? Well, the nice thing is we only have one option, and that would be x times x gives us x squared. All righty, so we have these. So we've taken care of the first, and then you look at the last term in the polynomial. What multiplied together gives you 6? Well, I kind of like to list them off to the side here. So 6 times 1 gives you 6. 6 times 1. And I guess I could put a dot rather than a comma. All right, what else gives you 6? Well, 2 and 3 give you 6. So we've got two choices for our last spot. We could use a 6 and a 1 or a 2 and a 3. Let's just go ahead and let's just use our first one, even though some of you probably know right now which one it's going to be. We're going to choose 6 and 1. Doesn't matter where you put the 6 and the 1, just in the last spot. All right, so here, going back up here, let me see what I've got. All right, we did the first spot and then the last spot. All righty. Now, what do you put inside? You put plus signs or minus signs? Well, when everything is positive, it's all plus. So we set it up using our first term and our last term. Now we check it using the OI. This OI tells us the middle term. So let's check it. Do we get 5x? Well, 1x, the outside, I is the inside, multiply those. Now when you combining your like terms, you get 7x. But 7x is not our middle term. So we can't use 6 and 1. So what we're going to do is erase it and try our other option of 2 and 3. Doesn't matter where you put the 2 and the 3. There's no specific order here. Now, checking it, so the first times the first gives us x squared. The last in each of these parentheses, last times the last, gives us the 6. Let's see if we get the 5. Outside using the OI. So we have 3x. When I multiply 3 times x, 3x. 2 times x is 2x. When I combine those, I get my middle term. So you're done. So you can either write x plus 3 or x plus 2. The order here doesn't matter. But you broke that polynomial into parts. Once it's in parts, we can work with it in solving. All righty. So again, this is kind of a guess and check method. A lot of times when you have a 1, you can say what multiplied together gives me 6. You can look at these choices and know I'm going to be adding to get the middle term. So you multiply, and then this term you add, because we're adding these. So what do you multiply together to get 6, but add together to get 5? And that could shorten your process of erasing by trying wrong ones. So the last term, what multiplied, middle term, if they're all positive, you'll be adding. There'll be some times where we'll be subtracting to get the middle term, and we'll look at that here in a second. All righty, let's go on to our next example. Again, look for our greatest common factor, a common factor here, and there is nothing. We have a 1, 11, and an 80. Nothing goes into 1, 11, and 80 other than 1. And the 80 doesn't have an x, so there's no common variable. Now, if there is a common variable, remember, take out the smaller exponent one. All righty. So we're not going to do that, so we're going to set up our parentheses. So again, leave space. You're going to be writing numbers in here. All right, so now we know that the first term, using our FOIL, we set up our parentheses using these two, and those two are a multiplication type idea. What multiplied gives you the first term. What multiplied gives you the last term. Here, we only have one choice. We're going to do some where you have a couple of choices. All right, we have a negative 80, okay, which means to get a negative, when we multiply, something's going to have to be positive and something's going to have to be negative. So let's list our possibilities here. Those of you that are fabulous with multiplication tables, it makes it so much easier. If not, maybe I'll try to do some strategies on how to find out everything that multiplied together gives you 80. 1 times 80. All right, that gives you 80. But when you add those together, you don't get 11. Or actually, one of them has to be negative. Let's make the 80 negative. One of them has to be negative. We don't know. So, but when you multiply, you get a negative 80. But when you add these, you get a negative 79, not 11. So let's try another one. I'm going to move this over. Sorry, I want to have room to put all my combinations. We set it up and we're on this last term here. Let's see, how about, well, even if you could always switch them, but all that's going to do is switch the sign on that middle term. When you add them, you get a positive 79. All right, how about 8 and 10? It ends in a 0. So we could do negative 10 times 8, or 8 times a negative 10. Oops, negative 8 times 10. Sorry about that. It's the same thing. There. When I multiply those, I get negative 80. But when I add those, you know, that's what I'm going to be doing with the OI method. I get a 2 or a negative 2. I have an 11. So what else gives you 80? Well, if it misses, if it ends in a 5, or excuse me, if it ends in a 0, you know that 5 goes into it evenly. So 5 times what? 5 times what gives you 80? Well, take 80 divided by 5, and that would be 16. So maybe a negative 16 or a negative 5 times a positive 16. All right, so 80 ends in 0, so I know 10 and 5 go into it. You know, so if you know some of those division rules, and how do you know if it's divisible by 3? You know, you add up the digits and see if that's divisible by 3. But all those, if it's even, I know that 2 would go into it. So you know, eventually we may need to try 2 times a negative 40, or a negative 2 times a positive 40. All right, all of those multiplied together give you the 80. So again, this could be an issue for some of you without real good multiplication tables, and I'll show you here a method or knowing your multiplications, but we can always get around it. So here, now let's look at this one here. Now when I added, I got 2 and a negative 2. Let's see if these would work. So multiplied, I do get the last term, but added, I get a negative 11. Ooh, this one, when I add these together, I get a positive 11. Looks like maybe that's going to be our combination. Multiplied negative 80, but then I check it to see if I get the middle term. Let's try it. It doesn't matter which one you make 16 and which one you make 5. So I'm going to go with a minus 5 and a positive 16. You could have put the positive 16 in the minus. It doesn't matter, these order. Okay, let's check it. Let's use our FOIL, go through it. The first times the first, here I can write it over here. The first times the first is x squared. The outside is 16x when I multiply those. The inside is a negative 5x when I multiply those. Combining like terms, I get a positive 11x. That's what we wanted. And the last times the last we know is a negative 80 because that's how we set it up. Now, if we hadn't gotten the 11, we would have had to have gone back and tried a different combination. So okay, so then we have our answer right here. I'll just rewrite as I've got all my little outside and inside arrows there. So we broke that polynomial apart into two parts, just like you can break 6 into 2 times 3, or you can take 12, 3 times 4. We're breaking it apart. We're factoring or fracturing and breaking it into parts to work with it. And that's what we've done. And it's just kind of a guess and check method. And as long as that's a 1, it makes it a lot easier. You can just kind of list them and multiply to get that, and then start adding to see if you get the middle term. Okay, but what happens if you have trouble with this process up here? Well, what you can do is you can take that 80 and you can break it into primes. Pick any using your trees. Hopefully the trees are kind of familiar. You can pick any two numbers. We could have used like 4 times the 20. That's something we hadn't even gotten to up here was 4 and 20. But it doesn't matter which 2 you start with, as long as when you multiply them, you get 80. And then you break those down. 4 times 2. And so you break those into primes. 4 times 2 is 8, and then 2 times 2 is 4. So we have this list of numbers that when I multiply them, 1, 2, 3, 4. When I multiply these together, I get 80. And what you can do to come up with these is look at different combinations of these, like 10, multiply those and get 10 and 8. 2 times 2 times 2. And if that doesn't work, so you just work with just this group. And again, we found out it was just 5 times the 16. But you can multiply different groups here to come up with possibilities that'll work here. All right, so that's just one way to help you. All righty, let's go on to the next page. Let's see. Oh, the next page is the Xbox method. I don't know if this is the next page on yours or not. Okay. No, I'm thinking, just a second, I'm going to pause this to double check that my papers are in the right order. So just give me a second. Okay, so this is the right order. All right, so now what we're going to look at is what happens if that leading coefficient has a number in front of them. What happens then? Well, we're going to introduce another method. It's called the Xbox method, if you would like to use that. And then again, we can also use the FOIL method, just as what we were using earlier. So we're going to go ahead and we're going to look at both methods on this one, and then we'll probably just practice the Xbox method on the next one. But I want you to see that you've got a choice here. And some people just, they find a method and they just stick with it and don't even use an optional method, and that's fine too. So here, looking at the FOIL method, okay, we've got 6x squared. Sometimes these take some more room. Again, look for what's in common, if there is anything. But there's nothing that would go into 6, 19, and 10 evenly. And the 10 doesn't have a variable. So we don't have a greatest common factor. But again, remember to look at that. All right, so what we're going to do is using the FOIL, all right, we're going to go ahead and set up our parentheses. But our first times the first isn't just x times x anymore, like it was earlier. We've got a 6 that we have to contend with. Now here, there's a couple of things you could put. You could use a 3 times 2 to get the 6. 3x and 2x. When our guess and check, we're guessing, and then if it doesn't work, we may have to go to the 6 and the 1. 6 times 1. In order to get the 6 and put 6x and a 1x. I'm hoping that the 3x and the 2x work. Now the 10, what gives you 10 choices? We could do 10 times 1 and put those in the spots, or we can use 5 times 2 and put those in our spots. You have to try them both. Let's go ahead and try the 5 and the 2 because I want to talk about something. All right, where would I put the 5 and the 2? Well, no, we'll just do the 10 and the 1. We'll just go in order. That 10 and 1 will work with the idea I wanted to get across. Where does the 1 go? Does the 1 go here or does the 1 go here? Well, the nice thing is, I'm going to go ahead and put the 1 here and the 10 here and tell you why this doesn't work. Right here, see how you can pull out a greatest common factor? You could pull out a 2 from these, so you know that's not right. There'll never be something in common you can put out. So you cannot put the 10 there. You can put the 10 here because 3 and 10 have nothing in common that would go into them. And the 1. Everything, oh, this is a positive. So I know that when I multiply these together, they both have to have the same sign. But this is negative. So it tells you that they both have to be negative. So this is positive, or excuse me, this is, yeah, since this is a positive, I know that the multiplying has to be the same. And since that's a negative, I know they're both negative. A negative times a negative is a positive. Do you get the middle term with that? Well, negative 3x when you multiply, and a negative 20x is a negative 23x, which is not a negative 19. So I know the 10 and the 1 aren't going to work. So I'm going to try the 5 and the 2. If the 5 and 2 don't work, I have to go back and change my 3x and 2x to a 6 and a 1 and try those. So you can see why people really don't like this. Okay, but the more you do, you kind of start to look at it and you're able to say, this combination I think is going to work a little bit better. All right, we cannot put the 2 here. All right, because you can't have a common factor within these parentheses. The 5 has to go here and the 2 has to go here. There's not a common within those groups. So a negative times a negative, we're going to get your positive 10. Let's see if we get 19 as a middle term, negative 19. We set it up. We know we get the first term by multiplying and the last term. Let's see, negative 15x, negative 4x when I multiply and multiply. Combining those, I do get my negative 19x. So you're done. I'm going to write this down. 3x minus 2, 2x minus 5. That's using the FOIL method, kind of the guess and check. We're going to look at another method. This other method is called the Xbox method. And, okay, so another method, and I know that some students really like the Xbox method, and they sometimes they use it on all the problems, and that's fine. Sometimes I think it's easier, especially with the 1 in front, to use this FOIL method, but that's okay. Let's look at the Xbox method. Okay, to start with the Xbox method, again, look for what's in common, nothing. You take your 6x squared minus 19x plus 10, and you make an x. And in this x, what you'll do is you multiply those two together. You multiply. I'll put a stars rather than an x. And that's what goes here, 60. Okay. And then what goes below is the middle term. All righty. So what you're going to do is you find out combinations multiplied together that give you 60 and added together give you negative 19. You look for those combinations. Well, how do you do that? You can, unless you're great with your multiplication, which is great, you can start with 60 times 1. You know that they have to both be negative because we're going to be adding them. And then you add to get a negative 61. That doesn't work. So then you go maybe times, well, I'm going to order this a little bit different. Sorry. Negative 1 times 60, negative 60. multiplied together give you that. Multiply gives you a positive 60, added gives you a negative 61. All right, works for here, works for that one, but not for that one. So you want to multiply to get that, but add to get that. Okay, let's try another one. Okay, so let's try -2. Does -2 go into the 60? Yes, it does, -30. So that gives us 60. And added gives you a -32. We need -19. So let's go to the next number. We did -1, -2. Let's try -3. 60 divided by a -3 is a -20. Multiplied, and the reason they're negatives is because I wanted a -19. So multiplied together, you get 60. Added together, you get a -23. That doesn't work. Let's try a -4. Sometimes these numbers don't go in and you just skip it and go to the next one. And then you just keep going down until you find a combination that works. I'm going to move this up just a smidge. So we're trying a -4. 60 divided by a -4 gives you a -15. All right. When I multiply those, I get 60. And when I add them, I get a -19. We can stop now. Otherwise, I would have done a -5, -6, -7 wouldn't have worked. I'd have gone to -8, which also wouldn't have worked. Or, yeah, so we just kind of keep going down the number line. All righty, until you find the multiplication and the adding. So now that we have these, you put a -4 here, doesn't matter actually the order, and a -15 on the other side of the box. So we'll repeat the whole process. Let me talk about it here. We're almost done. First off, you multiply the outside numbers, and then you put the middle term. And then you start saying, okay, what multiplied together gives me the top number, but added together gives me the bottom number. And you just keep going down until you find that combination. This is called the Xbox method. All right, so it's kind of the Xbox method with a little twist, and this is a little twist. You set up your parentheses, and you always put the leading term in both spots every time. Always. You always put the leading term will always match those. And then you put what you found, a -4 and a -15 in the second spot. So this is a little bit different, is to put those right there, but this works really well. So you copy that leading term, and now you reduce these. What goes into here? What's a number that goes into here? And you divide them both by that number. So you reduce those, pull out what's in common. You're just not going to put it in front. So I can reduce these by dividing by 2. Okay. What goes into 6 and 15? The largest number, 3. So you divide them both by 3. And that gives you 2x minus 5, which is the same answer that we got using our, what did I do with that? Here was our guess and check, using the first term and the last term and manipulating it around until we got the middle term. And this is the Xbox method, where we multiply, and then we put that middle term there, and we just start going through the list. And then you always copy down that first term, put these in there, and then reduce, and you're done. All righty, let's try the Xbox method again. Even though with this one, I would probably not use the Xbox, I would use the FOIL, because you only have one option for this one. It's not like there's multiple options. All right, but we're going to go ahead and look at our Xbox method. Because, you know, Xbox, and you're going to see this in other math classes, other teachers will talk about the Xbox, and now you know. In the top number, I take a -8 times 3, and I get a -24. All righty. And then I put the negative 10 down. So we're going to start finding numbers multiplied together give you a negative 24, but added together give you a negative 10. So let's say we've got our multiply column, and we have our add column, and we'll just start with 1. Now, I know that one of them has to be negative because when I multiply them, I need a negative. So we'll just start with this one being negative. So that gives you a negative 24, but when you add them, you get a negative 23. Nope, not a negative 10. So we're going to do 2 times a negative 12. Just divide that by 2 to find that next number. And let's see, that gives you negative 24 and a negative 10. Looks like we're done already. Otherwise, I would have done 3, 4, 5. I would have skipped because 5 doesn't go into there evenly. 6. All right, until we come up with the right combination. Now, if we would have come up, maybe we wanted a positive 10, you just switch those signs to make it positive. All righty. So now we have our answers here, a positive 2 and a negative 12. So we write down, we take our 3x squared and we put it in both spots, both beginning spots, and we put the 2 somewhere and the minus 12. Either spot. You can switch them if you want to. So this one cannot be reduced, but this one can because 3 goes into both of them. So divide them both by 3. The first one's going to stay. This gives us x squared minus 4. Now, you guys, you can multiply these together using your FOIL, and you'll come back to the original. So we've just factored this, broke it into parts in order to work with it using the Xbox method. All righty, perfect. All righty, so you can use the Xbox method here, is what we're saying. You know, you can use the Xbox method if you want to. 1 times 20 is 20, and that's a negative 9, and you just start listing, and you'll come up with these two, and then you put x squared. Or you can use the FOIL method here and ask yourself, what multiplied together? There's no leading coefficient, so what multiplied together gives you 20, but added together gives you a negative 9. Well, let's see, you've got, it's not 1 times 20, negative 1 times a negative 20. They have to have the same sign, and they both need to be negative because you want a positive when you multiply them. No, let's see, what else gives you 20? Negative 4 times a negative 5, and that may have been obvious to a lot of you right away. If not, 2 and 10. You know, you'd add 12 then for the middle term. But here, these multiplied together give you the positive 20, added together give you the negative 9. So x times x gives you x squared, minus 4 minus 5 gives you, multiplied gives you that, negative 4x and a negative 9x when you multiply those. Excuse me, not 9, 5. I was thinking of the answer. You get a negative 9x. So you can use the FOIL, or you can just start multiplying to get this and adding to get this, and find your numbers and then put your, oh, wait a minute, x. I think going back, sorry. No, that's, with that Xbox method, sorry, you don't put the x squared in there. Oops, sorry about that. So you have to go back. I don't, no idea what I was thinking. It's just a 3x and a 3x. Sorry about that. I think I did that twice. Did I do that on the other one too? And let me look. with the 80. Maybe that wasn't our first one. Sorry, you guys. Oh, yeah. I don't know. It's weird. You don't put, you just put the 6x. Sorry about that. You're going to have to go back in your notes. You just put 6x and 6x. Not with the x squared. Sorry about that. I just noticed that. Ugh. All right. Okay, so after you find these numbers, I want to make sure it's clear, you just go 6x and 6x. Those match. Bummer. All right. So here on the previous page, you just put 3x and 3x. So I guess it doesn't exactly match that. Bummer. So on this one, if we were to use the Xbox method, we know we're going to have a -4 and a -5 multiplied together, give you that, added, give you this. So then when we set these up, it's just 1x and 1x. You have a 1 in front. And then -4, -5. Okay. All right. Perfect. Okay, let's just practice some of these methods. And you can use any of the methods. Again, we'll start with the greatest common factor, and then you can use your FOIL, you can use your Xbox, and then some of you may know other methods, and that's fine as well. These are the only ones that we're going to go through in the class. All right, you look for the greatest common factor. There isn't a coefficient that goes into all of them, but they do have an x. The smallest is x to the first, so that's what I will pull out. And this divided by this, you end up with an x squared because you're subtracting exponents, this divided by this, or you know that x squared times x gives you x cubed. All righty. Here we have a minus, this divided by this is just an x. Check it, multiply, go back to the original. This divided by this, the x's cancel and it's just -30. So once you've done that, multiply it through and go back to the original just to double check that something simple didn't happen. Okay, so now we're going to use what's left inside. We're going to see if we can factor that, what's left inside. So here, we have a leading coefficient of 1. So normally I don't use the Xbox method if it has a leading coefficient of 1, but that's up to you. So we're going to be factoring this. Okay, and then putting it here. What multiplied together gives you -30, but added together gives you a -1. Well, we've got negative, I know it's not a -30 times 1. That's just a -29. -10 times 3, but that gives you -7 when you add. Let's see, -6 times 5. I'm leaving the first one negative because I know that my answer will be negative when I add them. You do get a -1. So multiplied. So we set up our parentheses. X times x gives you x squared. And so we have that. And then we have the -6 and the +5. Let's double check and make sure that we come back to the original. The first times the first is x squared. +5x outside, inside. When you multiply, you get a -x. The last times the last gives you that. So my full answer is x. Don't forget about that x. Make sure you include that in your answer that you took out. And then we have x -6, x + 5. Now, if you were to multiply these together, I would multiply these two together first and then times the x next. Okay, so that would just be the easiest. It doesn't matter the order, these three numbers, the order that you're multiplying. So it's a lot easier to take care of these first and then just multiply by the x. Okay. All righty, let's look at the next one. What they like to do here in Pearson in my math lab with this one right here is they want you to put it in descending order. Now, is this the only way to do that? No. All right, some of you might just keep it this way and factor it, but we'll just go ahead and follow their method. So they always like to have the leading coefficient with the highest power plus x plus 56. And what they suggest you do now, because before you start factoring, is the greatest common factor. Whenever this is a negative, your leading coefficient, go ahead and factor out a -1. And then that'll make that a positive x squared. That divided by that is a minus x. That divided by that is a minus 56. And if you multiplied, you'll come back to the original. And then they factor what's inside by asking themselves, let's just look at the x squared. What multiplied together gives you a -56 and added together gives you a -1. Well, we have a -56 times a +1 would work here for the multiplying, but the adding gives you a -55. The other one would be a -8 times 7. All right. It's probably one of the most commonly missed multiplications is this one right here. Multiplied together give you this, but added together give you that. So we've come up with our two numbers that should work. X times x is x squared minus 8 and a +7. But let's check it. X times x is x squared. The outside, 7x. The inside, -8x, is a -1x. The last times the last is a minus 56. So it does work. So our answer, don't forget the -1 outside. You got to make sure you include that. X minus 8, or you can put this +7 first. It doesn't matter the order that you write those two in. And we're done with that one. Okay, let's look at this one right here. Now we're going to solve. So now we're going to take it a step further. We're going to factor, just like we've been doing, using whatever method we would like to. And then we're going to solve it. So here we're going to look for the greatest common factor of 6x to the 4th, negative 116x cubed minus 80x squared. What's a number that goes into all of these? A lot of times 6 does not go into 80. So, I always try to get that to a 1 by, maybe hopefully everything can be divided by 6, but they can't. The highest thing that you can divide into each of these, you could try a 3. It's not going to work. And so it looks like just a 2. So I kind of worked with this. I know you can divide this by 6, 2, or 3. So I tried all of them, hoping it was a 6, but it's not. It's just a 2. So we have a 2. Now we have to look at the x's, the greatest common factor. Well, they all have an x, and the smallest is x squared. So that's what I'm going to take out. All right. So then here we're going to get 6x to the 4th divided by this is 3x squared. This divided by this, negative 116 divided by 2 is a negative 58. Subtract the exponents, x to the 1st. Check it. Yeah, it works. And then here is going to be a minus 40. 80 divided by 2 is negative 80 divided by 2 is 40. And then the x squareds cancel. Multiply it. Sometimes you have a 1 here, so I just don't want you to forget that. But you multiply it out and make sure you get all 3. Okay, now we're going to factor what's left inside. And here, some of you may want to use the Xbox method. You could use the guess and check with the FOIL, because you only have one thing for this times this gives you that, right? And then you could just kind of work with the negative 40 and put them in here, like -8 and 5. You could try that in these spots because those multiplied together give you this one. So you could put it here, -8 and a +5. And then see if that gives you a -58. It doesn't look like it's going to. It's going to give you something pretty far from, you're going to get 15x and a -8x. That's not going to be -58. It's just going to be a -7 or a +7. All right, so then let's try, those just don't seem big enough. Let's try 2 and 20. We have to make one of them negative and one of them positive. Doesn't matter which. Let's go with a -2. Just guess. So we'll put in a 20, +20, and a -2. You could have used 10 and 4, just all these different combinations. So here we have a -6 and a +20. That's 14. So let's switch them. Switch the 20 and the 2 and see if that combination works. -60 and a +2x. When you multiply those, and we do get our -58. So, if you like the Xbox method, it would have ended up the same as well. You'll end up with the same answer. So we did find the right combination, and that we did have to change the signs there, but we did get the right combination. All right, now we have our next step, which is that zero product principle. Now we have to solve it. So we broke it apart, and I know that I'm multiplying these together. One of them has to be 0. Okay, so this one we talked about in the last section. You've got a 2x times x. It's just solving this. It just is x equals 0 when you solve that. What multiplied together? The only number you could put in to have this be 0 is 0. So you have one solution. So when you have an x out here, you're going to have a 0 for a solution. Yep. And now here, you take 3x plus 2, and you solve it. -2. So I'm saying, okay, the second one is 0. Divide by 3. X is a -2/3. So we're finding x-intercepts here, actually, as well. Remember, these solutions, these zeros, these roots are all x-intercepts, where if you were to graph this, it would hit the x-axis. And then the last one, maybe this one is 0. We only need one of them. Add 20, x equals 20. So our solutions are 0, -2/3, and 20 for our solution for that. All righty, so we're factoring in order to solve. And sometimes they're a little tedious, trying to come up with that right combination. All righty, let's look at our next one. Here, this one looks familiar. Did we do something with I thought we did something with the 6x. That way we don't have to refactor it because we've already done it. Yeah, maybe. Yeah, we did. I don't know if it'll be exactly the same. It may not be. Yep, it is. All right, so we look for the greatest common factor here. And there's not a number that goes into 6, 19, and 10. All right, so, but they all have this x. Well, also, I just noticed that because these two are like terms, you do need to simplify before we even start. So you have to combine those before we start to factor. So you do need to simplify that left-hand side. And you do need to make sure you have a 0 over here. If not, move it and simplify it if there's something over here. But this is actually simplifies everything quite a bit. We have 16x to the 4th minus 19x to the 5th. for this one right here. Now, before we always says, well, you know, you just told us in a couple problems before to put the highest power first. So we'll do that. So we've simplified, you know, we put the highest power first. Now we're ready. Look for what's in common. There is something, there's some variables. And also if that leading coefficient is negative, bring out a negative. So we do know we're going to bring out the negative. And we have x to the fifth and x to the fourth common. And we'll take out the small. This divided by this divided by this is going to be a positive 19x, subtracting exponents. Check it, multiply, make sure you get that term. Okay, this divided by this will be a minus 16. Positive divided by a negative is a negative. And the x to the fourths cancel. Multiply it, make sure you come back. Now, you can't factor this any further. You're done factoring. Whereas before, when we took out the greatest common factor, what was left, we tried to see if we could factor it, and we could. Okay. Now, here we'll set each of these equal to 0. When is that going to be 0? There's only one possibility. And when is this going to be 0? The only way you can multiply 4 numbers together would be if they, and to get 0 would be 0. 0 times 0 times 0 times 0 is 0. So we have 0 as a solution. And then we add 16. 19x equals 16. Divide by 19, kind of running into the other one. X is 16/19. So we have 2 solutions here, 0 and 16/19. And we found that by factoring. You know, we're doing some rearranging and some simplifying, but the factoring tells us. All right, let's look at another one. You have to set it equal to 0. You have to have a 0 on one side. Now, I'm not going to move these over here because then that makes this negative. I'm going to move this over. If this were negative, I'd move it to the other side because you want that leading coefficient positive, minus 4. So we have 3x squared minus 4x minus 4. Okay. So now we look, see if we can simplify it. It's simplified as far as we can. Taking out the greatest common factor, doesn't look like there's one that goes into 3, 4, and 4. So we'll just go ahead and start using our, I'll just use the 3x times x. Okay, now on this one, you could use 2 and 2. What multiplied together gives you that. 2 and a negative 2. It could also be a 4 and a negative 1, or a negative 4 and a positive 1. You know, it's, you know, let's just try the 2 and negative 2. Let's do negative 2 and a positive 2, just to see. Do we get the middle term? Okay. These combinations. Positive 6x and a negative 2x is a positive 4x. So we've got the right number, but not the right sign. If that happens, switch your signs. So now we have a negative 6x and a positive 2x when we multiply those, which gives us that. All right, so we were able to break it down. We were able to factor it so we can work with it. And we set each of these equal to 0. One of those numbers has to be 0. One of these 2 numbers. Each of these parentheses represents one number. So we subtract 2 and then divide by 3. So one of our x-intercepts is a -2/3. It'll either cross or touch at a -2/3. And then we have +2. So we have -2/3 and 2. You could check, you could actually put it back into here and you would get 4 because you want it to equal 4. If you were to put those values back in, the left would equal the right, or put them back into this and you'll get 0 for your solution. All right. So far so good. Okay, so I know that the notes are done, but I wanted to talk about one thing, and that's if primes. All right, we do have, like, 6 is not a prime number because you can break it down, which is what we've been doing with polynomials. 5, however, 5 cannot be broken down, just 5 times 1, that's all you get. So this is called prime because it really can't be broken down into anything other than 5 and 1. So do we have primes with these polynomials? Yes, we do, when we're trying to factor. So how do you know? Well, let's look at kind of a quick example here. Sometimes you may end up with a prime. We don't normally do that very often on the homework. But if you had something like this here, and you were to try to factor this, you would have to come up, everything's positive, okay? Multiplied together that give you this, but added together give you a 1. Well, the only possibility I have is 5 times 1. That's it. That's the only choice. But I don't get 1. I get 6x. All right, so if that happens and you've tried the combinations and nothing seems to work, then we say that this is prime, and you would click the prime button. That will always be an option in these factoring. All right, so that doesn't happen very often, but it can. So I just kind of wanted to touch on that a little bit. All right, if you have any questions on factoring, please let me know, and I'll help you out. All right, bye-bye.